gate are two. Okay, they are NAND and they are NOR. Okay, these are known as universal because they can make any of the other gates. Okay, you can make OR gate, you can make AND gate, you can make NOT gate. Black and blue pen, that means I am writing A plus B. Can I write here that this is equal to A plus B? Why? Either bring A or either bring B. If you remember, if I go to the addition one, so from addition you can see that when I was doing addition, when I was having any one input as high, the answer was high. When any one was high, the answer was automatically high. That means it is not compulsory to have both of them. Even if I have one high, the answer is high. Even if I have one high, then answer is high. Therefore, the addition one is known as AND gate. Okay, why? Because any one high input, okay, produces high output. Okay, the reason of why what I am naming this as OR gate, because if any one of the voltage is high, the output is automatically high. Okay, why the AND gate is why the multiplication gate is known as AND gate? Because I am not concerned with only with any one value. I am concerned with both of the value. Okay, I say that if this is equal to A dot B, the multiplication gate is known as AND gate, and the reason is so obvious that I am talking about both of them. Okay, when both of them are high, okay, or I can write this as when both inputs are high, okay, output is high. Okay, output is high only on the condition when both of the inputs are high. If any one of the input is also low, the answer turns out to be low. Okay, got it? Are you able to process that? Okay, so why did I say that this is and this is OR gate? So OR gate, because if any one is high, the answer is high. If both of them is high, only then the answer is high in case of AND gate. And why I am saying that the inversion gate is known as NOT gate? Okay, because this is equal to A naught is equal to the opposite of what it is being given. Okay, if I say because if high, okay, if high input is there, so it will turn the high input into low output, and if I am having a low input, that will turn into a high output. Okay, so this was the common thing that we have to note, that why these gates are named as such. Okay, I hope that is clear. So these were the gates here. Okay, so we have now made our discussion just about the fundamental gate. What are the universal gate? So universal gate are two. Okay, they are NAND and they are NOR. Okay, these are known as universal because they can make any of the other gates. Okay, you can make OR gate, you can make AND gate, you can make NOT gate using the NAND or the NOR gate. Okay, therefore they are universal gate. We can take any other gate out of them. Okay, and what are the special gate? Well, special gates are known as XOR gate or XNOR gate. What are XOR and XNOR? We'll be knowing this at the end of the topic. Okay, but by this time this was enough for us to know. Okay, let us start the discussion in detail. Let's discuss them in detail. So first we are taking with NOT gate. First we are dealing with the NOT gate. What is the NOT gate and how does it function? Okay, NOT gate, first thing, okay, the NOT gate is based on inverse operation. Okay, it is based on the inverse operation. Okay, this is a fundamental gate. It is a fundamental gate as stated. Okay, it is formed, okay, this is something which you should note. Okay, it is formed using a transient. Okay, so remember that my NOT gate is made using a transient, and this is definitely not of your importance, so you can just skip that also. But if you note this, then definitely this is good for you. Okay, what is the Boolean expression for this? Okay, the Boolean expression for this is as y is equal to a dash. Y is equal to a bar, or you can say a dash. A dash means that I am doing the inverse of this. Okay, and most important, what is the circuit symbol? Basically I will be using these gates. These gates are a part of the semiconductor, right? So I will be using them in my circuit. So the circuit diagram is like this. Okay, let me draw the circuit diagram with black. The circuit diagram is like this. Okay, you can note here, just note it clearly, that there is a this is an input. Okay, in this input I am putting an input. Let's say I am putting an input of A. So what is the output that I will be getting? The output here is equal to A dash. The output represented by the equation y is equal to A dash. Is that clear? So how many inputs are here? You can say that there is a single input. Okay, well, sorry, We are having here single input. Okay, let us draw the truth table for this. Okay, the table which I have been telling you as the circuit chart. Okay, this is known as the truth table in the technical language. Okay, let us draw the truth table between the input and the output. If my input is A, okay, what do I get the output? My output is A dash. Let me write it again. If my input is A, what do I get my output? My output is equal to A dash. Okay, that means if my input is 1, I will get the output as 0, and if my input is 0, I will get the output as 1. I hope that is clear. Okay, you understood the truth table for this? Okay, good to hear. Okay, let us draw the graph for the time scale. Let us draw the time scale. What does time scale means? Okay, let's say that this is my input A. If my input is low, okay, my output is my output is high. Okay, my output Y is high. Okay, let's say that this is ground for the A, and this is something like this. Okay, this is 0, this is 1, this is 0, this is 1. So when my input is 0, my output is 1, inverse of that, and when my input is 1, I will get my output as 0. Okay, I hope this is clear. Okay, again, if I say that your input is 0, you will get that your output is high here. Okay, I hope that is clear. This is the time scale that has been drawn for the NOT gate. Okay, so is there any physical existence of the NOT gate? Like I just mentioned that, yeah, NOT gate, in the NOT gate, these many things happen, and these are the things that happen in this way. Okay, but how can we make a real life NOT gate? To make a real life NOT gate, you can make it like this. Okay, basically I am doing the electrical realization. What does electrical realization mean? Let me show you of how this exists. Okay, of how this exists. So if I say that I am having a circuit, this is the current, sorry, this is the battery, and to this battery, okay, a bulb is connected. Okay, the bulb is connected, but in between I have put a key. The key is parallel to the circuit. This is the bulb. Okay, what does NOT gate says? The NOT gate says that if my circuit is if the key is off, the bulb should be on, and if the key is on, the bulb should be off. Okay, well, you can find that this is true. Okay, how? You can see that when the key is off, entire current will be passing through the bulb, and the bulb will glow. When the key is off, the entire current will be passing through the bulb, and the bulb will start to glow. But the moment when you turn the switch on, okay, you just turn it on, what will happen? The entire current will pass through this naked wire. Why will the current go into the bulb and will lose its own energy? Okay, why will it lose its own energy? That is not a good thing. Okay, therefore this is the electrical realization, that when your input is high, your output is low, and when your input is low, the output is higher. Is that clear? Okay, this is the electrical realization that you have to note. Okay, I hope you are done with this. I hope you have understood this. Okay, so this is the electrical realization. So electrical realization says that place a key in parallel. Key is parallel. Is that clear? Okay, sounds good. Let us discuss the first gate of NOT gate is clear. Let us take our second fundamental gate, and that is AND gate. Let us discuss something about AND gate. So what are the things that I have to discuss about the AND gate? The first thing, this AND gate is based, okay, it is based on product, or it is based on multiplication. The AND gate is based on multiplication. Okay, mind this and remember this, that the AND gate is based on multiplication. The second thing is that it is a fundamental gate. I know that it is a fundamental gate. The third thing is that it is formed using a diode. Okay, formed using a diode. Okay, the fourth point is, what is its circuit symbol? So the circuit symbol is, get it very clear. Okay, there are two inputs for this. One input is A and the other input is B, and it looks something like this. Okay, the circuit symbol is something like this. Its back is straight and the front portion is curved, and from here an output will be there. The output is Y, and the value of Y is equal to A plus B. Is that clear? Is the value equal to A plus B? No, the value of output is A dot B. Is that clear? This is the Boolean expression. Okay, the Boolean expression for this is Boolean expression for AND gate. This is equal to Y is equal to A dot B. Is that clear? What is the main key feature about the AND gate? Okay, when you will find that your output is high only when the inputs are high. only when both the inputs are high. Only when both the input are high. Okay, and what about its the output to be low? So the output is low. Okay, when any one of input is low. Any one input is low. So if any one of the input is low, the output will be low, and when both of the inputs are high, the output is high there. Is that clear? Let's draw a truth table for that. So how does a truth table looks like? So if I draw the truth table for this, the truth table between the input and the output. Okay, my input is A.
The problem is not effort. It's lack of personal attention. With one-to-one mentoring, every doubt is addressed, every concept is applied, and real improvement begins.